Welcome back. In today's lecture, I'll discuss the assignment which I gave you in the previous lecture on some problems of differentiation and integration. So let's start one by one, starting from differentiation. So this was relatively easier question. This is dy by dx. What you need to do? You need to differentiate this one by one. All these terms are differentiated one by one. This is 4 into 3. So this is 12 x cube. If it is initial power was 4, now the power becomes 3. Then if it is minus, I write down minus 7 into 2, 14, and then x square becomes x. Then the third term is 5x raised to power 1. So this becomes 5 into 1, 5 into 1, this is 5, into x raised to the power 0, and x raised to the power 0 is 1. So 5 into 1 is 5. This is a constant and its differentiation is 0. That's the answer. Let's come on to the next question. This question you can do by two different ways. Either you consider it u by v, or you can change it like y is equal to x squared plus 3 raised to power minus 1. Now this question becomes the question suitable for applying chain rule. How do we do that? dy by dx will be equal to, this minus 1 will come over here, and the bracket will have power minus 2. You need to reduce power by 1. It was already minus 1, so it becomes minus 2. And then multiply it with the differentiation of the term inside the bracket, that means u. So differentiation of this is 2x plus 0. That's the answer. Let's move on to the third question now. Again, this is a suitable question for applying chain rule. dy by dx will be equal to 3 times under root x minus 1 by under root x raised to power 2 multiplied by differentiation of something which is there inside the bracket. The differentiation of under root x would be 1 by 2 x raised to power minus 1 by 2, and this is minus, this will go up there and it will become x raised to power minus 1 by 2, so it becomes minus 1 by 2 x raised to the power minus 3 by 2. That is the answer. Let's move on to this thing. Now in this question, you are given theta and you have been asked to find out angular velocity. Now angular velocity denoted by omega is nothing but d theta by dt. So just simply differentiate this expression. So d theta by dt will become 4 times t cube divided by 60 minus 1 by 4. So you can simplify it. This becomes t cube by 15 minus 1 by 4. And you have been asked to find out velocity at t equal to 10 seconds. Just put in the value of t as 10. So this becomes 1000 by 15 minus 1 by 4. The units of angular velocity are radians per second. That is the answer. Let's move on to the next question. This is a suitable question for applying u by v, or you can also do it by other ways, but I'll give you a simpler way. It is mathematically a little, algebraically rather, a little tedious, but mathematically it is easier. So how can we do that? So dy by dx, whatever is there in the denominator, you just square it, so it becomes 3x square minus 4, square and under root get cancelled. Then you write down the same thing over there, 3x square minus 4, and multiply it with the differentiation of 3x, which is 3 minus, then you write down the numerator without differentiation and write down the differentiation of the denominator. The differentiation of the denominator is, it will become 1 by 2 3x square plus 4, 3x square minus 4 raised to power minus 1 by 2 into 6x. The chain rule has been applied over here. So these are the solutions to the problems which I gave you on differentiation. Let's now move on to the integration part. If you don't follow any step, you can message me. I'll elaborate that once again. So integration of this, what you need to do, you need to change the configuration, the shape, the appearance of that expression into that that way that it is similar to the formulas which you know. For example, you know the formula for integration of x raised to power n. It is given to be 1 by under root x. So what will you do? You will simply change it as x raised to power minus 1 by 2 dx. Now it becomes x raised to power n dx. So apply that formula. The integration would be x raised to power minus 1 by 2 plus 1 by 2 divided by minus 1 by 2 plus 1 by 2, and of course plus constant of integration c. You can simplify that later on. Now what about this? Cos x over 1 minus cos square x. What you can do? You can write it down as cos x over 1 minus cos square x. It becomes cos x over sin square x dx. You can write it down something like this: 1 by sin x into cos x over sin x. It becomes secant x cotangent x, cosecant x cotangent x dx, which is nothing but, we know, cosecant x minus cosecant x. The integration of cosecant x cotangent x is the integration of cosecant x cotangent x is minus cosecant x. Then we have got this 1 over sin x. You can proceed it like this. There is no direct formula which you can relate to this kind of expression. So what you do, you rationalize it. 1 plus sin x over 1 plus sin x dx. You can write it down as 1 plus sin x divided by 1 minus sin square x, which is cos square x. So it becomes integration of secant square x plus integration of 1 over cos x into sin x over cos x dx. Now integration of secant square x is tangent x, and this becomes secant x tangent x. Secant x tangent x. I know the integration for that is secant x. So this is the answer. Now let's move on to the next question. The integration of 7x cubed plus 3. The limits are from minus 1 to plus 1. So what you will do, you will first of all integrate the expression as such that it becomes 7x4 by 4 plus 3x. Now first of all, you will put the upper limit. So it becomes 7 by 4 plus 3. I have put x, I have replaced x by 1 minus, then you replace x by minus 1. So it becomes again 7 by 4 minus 3. Simplify it, that would be the answer. Now let's do the last question. The last question says cos x dx from minus pi by 2 to pi by 2. I know the integration of cos x is sin x, and limits are from minus pi by 2 to pi by 2. That becomes sin pi by 2 minus sin minus pi by 2. Sin pi by 2 is 1, sin of minus pi by 2 is minus 1, that's equal to 2 square units. That's the answer. I hope you have followed these questions. For more problems, you can follow my book, Systematic Physics by Giuliani Publishers. Thank you.